Hello and welcome to our lesson on operations with polynomials. So we started with some vocab, talked about what it means to be a polynomial and how to classify them more specifically based on the degree and number of terms. And in the last topic we looked at some exponent rules, which really does incorporate some operations. What we looked at was multiplying, dividing, and raising polynomials to powers, but they were typically all going to be monomials, right? All single terms. So a single monomial multiplied by another monomial, a monomial divided by another monomial, a monomial raised to a power. What we're going to do today is expand on that. So we're going to expand on the operations. We're going to look at multiplication and division again, but multiplication and division with larger polynomials. And then we're also going to throw in there addition and subtraction. So if you recall, I mentioned in the last topic that there are no exponent rules for addition and subtraction. When you add and subtract polynomials, the exponents don't change. You're simply going to be combining like terms, okay? But we will, again, revisit multiplying and dividing with larger polynomials. So let's start with the addition and subtraction piece. To add or subtract polynomials, again, you're combining like terms. Now, when I say combine like terms, so let me throw an example out here. Let's say we had a 5x squared and a 4x squared and a 3x and, I don't know, a 7x, okay? There are two sets of like terms here. These two terms would be like terms, and these two terms would be like terms. What does it mean to be a like term? It means that the terms have the same variable with the same exponent. So the first two both have an x squared, and the second two both have an x to the first. Alright, so when we have like terms, we can combine them, add or subtract whatever the operation is. But what are we actually doing when we combine them? What are we actually combining? So if I had just a 5 and just a 4, we would combine those and say, well, that's going to be 9. Well, it's similar here, it's just that I have 5x squareds and 4x squareds. So what do I have when I put those together? I have 9x squareds. What we're combining when we combine the like terms are these numbers in front of the variables, which we call the coefficients. Okay? So similarly on this side, if I just had a 3 and I said, well, let's add the 7, then we would have 10. So then if I have 3 x's and I want to add 7 x's, then what I have is 10 x's. Okay? So we are trying to combine the like terms, and really what that means is combine the coefficients of the like terms. Let me try that again and try to make it fit. We're going to combine the coefficients of the like terms. And again, what it means for our terms to be like is they have the same variables and the same exponents. Okay? Again, exponents are not going to change when you add or subtract. If you add x's with more x's, you are still going to have x's. If you add x squareds with other x squareds, you will still have x squareds. Okay? So if we look at the first example, we have this quadratic trinomial, and it says to add a quadratic binomial. Now the parentheses are in there to separate the two polynomials, but in reality the parentheses don't mean anything to this particular problem. The only time we have to worry about parentheses is if there's something outside of it to distribute or to multiply. For example, if I had, let's say, a 4 here, then those parentheses matter because they're telling me that the 4 would have to distribute to all of the terms in the parentheses. But right now, what's sitting outside of the parentheses is technically a positive 1. And distributing a positive 1, multiplying by positive 1, changes nothing. So although there are parentheses to separate these polynomials, they do nothing to this problem. So I'm going to go ahead and rewrite all of these terms without the parentheses, just so we see that these are the same. So the positive 8x squared minus 2x, all these terms can come out of the parentheses. Okay, so we're going to combine like terms. And because it's proper to write our polynomials in descending order, I'm going to start by combining the terms with the highest degrees. So I'm going to start with the negative 7x squared that can be combined with the positive 8x squared. And so when I combine those coefficients, the negative 7 and the positive 8 gives me a positive 1 in front of an x squared. And we can write the 1, we don't have to either way. And now I can combine the 13x and the minus 2x. And if I combine those coefficients, a positive 13 minus the 2 is going to leave me a positive 11 in front of the x. And then I have a constant, and it's just one constant, so I'm going to bring it down because there's nothing to combine with it. And so this would be my quadratic trinomial answer. Okay, that is the simplified result of adding those two polynomials. All right, now if you look at number 2, the parentheses are going to matter for one of the polynomials. So we have this polynomial, and it says to subtract this one. In this particular problem, the first set of parentheses don't matter because, again, multiplying by a positive 1 doesn't do anything. So in my first for my first polynomial, I can remove those parentheses. So I'm going to bring down my minus 2x and minus 6x squared. Now the second set has a negative in front. That's like having a negative 1 here. And if I multiply by a negative, what happens? Well, that negative times that negative makes a positive 9x squared. And that negative 1 times that negative 3 makes a positive 3. And when that negative 1 multiplies by that positive 13x, it makes it a negative 13x. So if it's a subtraction problem, be sure to distribute that subtraction, which is like multiplying by negative 1. And basically what happens when you multiply by negative 1 is all of the signs change. This became positive, and this became negative. Okay? So now that the parentheses are gone, we're ready to combine our like terms. And again, let's start with our highest degrees so that we can get this in descending order. So negative 6x squared and positive 9x squared. When I combine those coefficients, negative 6 and positive 9 makes a positive 3 in front of our x squared. And now I can combine the negative 2x and the negative 13x. So a negative 2 minus 13 is going to be negative 15 in front of our x. And then I have a positive 3 and no other constants to combine with it. So I'm going to bring that positive 3 down, and that is my quadratic trinomial result. Okay, so adding and subtracting, hopefully we've seen a lot of this before, and this is just good review for us. Combining like terms, just be careful with your signs. Make sure that you distribute the negative if there's subtraction. Okay? Alright, let's move on to multiplication. We saw multiplication in the previous topic, but again, it was just multiplying a monomial times a monomial. So to multiply monomials, what are we doing? Do you remember from the last topic? When we multiply monomials, we're applying the product rule just once. We said let's multiply our coefficients and let's add our exponents. So that's what we have going on in problem number 3 here. This is a monomial here and a monomial here. Single term times a single term. So we apply the product rule a single time, just one time, where we multiply our coefficients. So the 5 times the 2 makes 10. And then we add the exponents for the like bases. So if I have 2x's here, and then I have 1x here, then the 2 and the 1 are going to give me 3 of those all together, so x to the third. And then we have y to the, let's see, I've got 4 here and 3 here, so that's y to the 7th power altogether. Okay, so we saw that in our previous topic, where the product rule that we apply one time says to multiply our coefficients and add our exponents. Now, if we're multiplying larger polynomials, like polynomials with multiple terms, it's the same thing. It's still the product rule. We just have to apply the product rule multiple times. So if we're multiplying polynomials with multiple terms, apply the product rule multiple times. So for instance, let's say you're going to multiply a binomial times a binomial. So something with 2 terms times something else with 2 terms. 2 terms times 2 terms is going to tell us that we should be applying the product rule 4 times. 2 times 2 would be 4. Okay, or if it was 2 terms times 3 terms, that would be 6 times we'd have to use the product rule. Okay, so let's actually, let's look at number 4 here. 2x minus 5 squared. Let's be careful with this. I don't know if this looks like a power rule problem to you. But power rule, we talked about before, would have been if I had like 2x to the 5th power, where each of these exponents gets multiplied by 5. That power rule only works for a monomial in the parentheses, so I can't apply the power rule here because this is a binomial. So we have to remember what it means to square something. What does it mean to square something? Like if I said 5 squared, what does that mean? It means take the 5 and multiply by itself, right? That's the same concept here. 2x minus 5 squared means that a 2x minus 5 has to be multiplied by itself by another 2x minus 5. So if we look at this problem, we are multiplying 2 terms times 2 terms. So I know I should be using the product rule 4 times. So let me show you where all these 4 pieces come from. So we're going to start by distributing the 2x, the first term in the first binomial. So I want to multiply the 2x times the 2x, and there's the first time I'm going to use my product rule. So 2x times 2x, if I multiply the coefficients I get 4, if I add the exponents I get 2. So 2x times 2x is going to give me 4x squared. Okay, now I'm going to use my product rule again. I'm going to distribute the 2x to the negative 5. So 2x times negative 5, I have 2 times negative 5, which makes a negative 10, and then just the 1x. Okay, I got 2 more times, and maybe you can see they're going to come from distributing the negative 5. So let's see. Negative 5 times 2x is the same thing we just did, so negative 5 times 2 is still negative 10, and there's going to be an x there. And then I've got one more. Oh, I can use red here. I've got negative 5 times negative 5, which is going to give me a positive 25. So there's 4 times we used the product rule, 4 terms as a result. Now this problem we're not done because hopefully you're seeing there are some like terms in the middle. So I'm going to bring down the 4x squared. There's nothing else I can combine with that, but I can put together negative 10x and negative 10x to make negative 20x's in the middle, and then I'm going to bring down my plus 25, and so this is my quadratic trinomial result. Okay? Alright, let's try that again. How many times are we going to be using the product rule here? Well, if I'm multiplying 2 terms by 3 terms, 2 times 3, that means I should be using my product rule 6 times. Okay? So the first 3 terms we're going to get from distributing the x. So let's start here. X times x squared. The coefficients are 1, so I'll still have a coefficient of 1. If I add those exponents, I'm going to get x to the 3rd power. And then, let's see, x times negative 3x is going to get me a negative 3 and an x squared. So that was 1 times negative 3, which is negative 3, and 1x there, and 1x there, which was 2x's altogether. Okay? And then let's see, x times 4 is going to give me a positive 4x. And now I got to distribute the 2, so we're halfway done. Distributing the x gave me the first 3 terms. I'm going to get the next 3 by distributing the 2. So when I distribute the 2, 2 times x squared is going to be 2x squared. Now I can continue to make this long list of terms, but I already know that I'm going to be combining this 2x squared with this negative 3x squared. So instead of continuing this in a line, I'm going to go ahead and write the positive 2x squared right underneath the 3x squared. So that way it's a little easier for me to combine them when I'm ready. Okay? Let's do this again. Let's see. When I distribute the 2 times the negative 3x, I'm going to get a negative 6x, which again I know I'm going to combine with that 4x, so I'm going to write it directly underneath. Just makes it easier for me to combine them. And then lastly, the 2 times the 4 is going to give me a positive 8. So if I put all this together, let's see. If I put all this together, what do I have? Well, I've got an x cubed. I have negative 3 and positive 2 combining to make negative 1 in front of an x squared. I have positive 4 and negative 6 combining to make negative 2 in front of x. And then I have a positive 8 to bring down. And that's going to be my cubic polynomial answer. Okay? So again, if you wanted to keep lining these guys up, make a big line over here, right? And then combine like terms, underlining, circling, triangles, whatever you want. That's totally fine. I just prefer when there are a lot more terms to organize them this way. Just makes it, for me, a little bit easier to go ahead and combine. Okay, but you've got the option. And it's alright, there's one left here in the multiply group. If you're feeling pretty confident with this, this would be a good place for you to pause the video and give this a try. Otherwise, let's go. Multiplying 2 terms times 2 terms means we should be using our product rule 4 times. So let's start here. 3x times 3x is going to give us a 9x squared, and 3x times negative 2 is going to give us a negative 6x. And then 2 times 3x is going to give us a positive 6x. And then lastly, 2 times negative 2 is going to give me a negative 4. So this is sort of like number 4 here, right? 2 terms times 2 terms gave me 4 results. Then I combined the ones in the middle. But on this one, what happens when I combine these terms in the middle? What happens with a negative 6x and a positive 6x? They're going to cancel. And so all we're left with is the 9x squared and the minus 4. And that is my quadratic binomial answer. So why did that happen on this one? Why did those middle terms cancel? Well, if you look at the binomials that we started with, it should make sense that the stuff in the middle was going to cancel, because those binomials were almost the same. They produced almost the same results in the middle. The only thing that was different was one had a positive, one had a negative. And so one positive, one negative made those two cancel, right? These two canceled out. Let me use the blue. Those canceled. And that is going to happen every time you multiply this type of binomial, or these types of binomials. These have a special name. These are called conjugates. So conjugates is the name for these binomials that have the same terms but opposite signs in the middle. And we're going to see a product of these. We're going to see it a ton. Okay, lots of these are going to be happening, and then we're going to deal with the end game too when we get into the next module. But it's not like I need you to know the word conjugates. Vocab is nice to know stuff. However, if you can recognize that you're multiplying conjugates, you know the middle terms are going to cancel, you can skip some of that work. And maybe you're not there yet, but like when I see, let me just show you what I'm talking about here. If I saw this 2x plus 1 and 2x minus 1, when I recognize these are conjugates, I'm not going to multiply all 4 terms because I know the middle terms are going to cancel. I'm strictly going to multiply here to make my 4x squared and here to make my negative 1 because I already know what's going to happen. And again, we're going to see this a lot, so if you can remember it, it will save you some work, but that is, again, nice to know stuff, so don't worry about it. So the product or middle terms always cancel when you multiply conjugates. Middle terms always cancel when you multiply conjugates. Nice to know stuff, okay? Okay, so those are some products. Let's look at my favorite of the operations, maybe yours too, which is division. And the first division we're going to look at is taking a polynomial of any size and dividing it by a monomial, by a single term. What we're going to do here is similar to what we did before. We're still going to apply the quotient rule. So when we were multiplying, we used the product rule. When we divide, we use the quotient rule. Now this quotient rule can only be applied when it is division by a monomial. So when the thing that's doing the dividing, the divisor is a single term. Okay, the divisor is a single term. Now let me just show you with some numbers first to make sense of it for you. Let's take this problem that doesn't have any variables in it. We've got 2 options to simplify this type of problem. We've got more than 2 options. You could use a calculator, obviously, but by hand, we could do the addition first. If we add first, if I add first, the 10 plus the 4 is 14, plus the 6 would make 20. So that would leave me 20 to divide by 2, and 20 divided by 2 would give me a result of 10. Or we have the option of dividing first. If I divide first, right, what I'm looking at is 10 divided by 2 plus 4 divided by 2 plus 6 divided by 2. So divide, 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 and then do the addition. Do I get the same answer? Okay, if I divide 10 by 2, I get 5. If I divide 4 by 2, I get 2. And then 6 divided by 2 is going to give me 3. Well, 5 plus 2 is 7, and 7 plus 3, it's still 10. Right? So I'm just trying to show you here, it doesn't really matter which route you take, you're going to end up with the same answer. So this is helpful when we're looking at a polynomial. Because if this was, let's say, a 10x squared and a 4x and a 6, well, I no longer have the option to add first because these are not like terms and they can't go together. So that leaves me with this other route of dividing individually. Okay, so that's what we're going to do here. We're just going to use our quotient rule a number of times, depending on how many terms are in the numerator in this case, which is the dividend, the thing that gets divided. So we're going to make this 3 separate quotients. So we're going to start by dividing here. 48 divided by 48x to the 5th divided by 3x squared. So 48 divided by 3, and remember you have a calculator, so don't freak out if you're not so good at dividing quickly in your head. 48 divided by 3 is going to be 16. So we're going to have 16x to the 5 minus 2, which is 3. And then we're going to divide again here. 6 divided by 3 is going to make 2. And we're going to have x to the 3 minus 2, which is 1. And then lastly, we're going to divide here. So negative 12 divided by 3 makes a negative 4. And then 2 minus 2 is going to give me x to the 0, which we know is just a 1. So then my answer is 16x cubed plus 2x minus 4. Box is so ugly. Sorry. I'm at the bottom of my iPad trying to write here, and so it's harder than it looks. Not that you care, but that's my excuse. Okay, so there's that guy. Let's try this once more. We're going to be using our quotient rule, our divide and subtract rule. Oh, I forgot to put that up here. This is divide and subtract, right? Divide coefficients and subtract exponents. So let's try it first here. So we have 15 divided by 5, which is 3. A to the 3 minus 1 is 2. And then b to the 2 minus 1 is 1. And then we're going to go again here. So negative 10 divided by 5 is negative 2. We're going to have a to the 2 minus 1, which is 1. And b to the 3 minus 1, which is 2. And then lastly, here. 30 divided by 5 is going to make 6. And then if I have an a here and a b here, and one ab on the bottom, those are both going to cancel, so just a 6. Oh my gosh. I'm sorry, I had a sneeze. That was driving me nuts for like the past 2 minutes. Okay. So that is that guy. That is my... What would this be? This is a trinomial with a degree of... 2 here and 1 here would be 3, so that's going to be a cubic trinomial answer. Okay? Now, here's the really fun part. If we are dividing by more than one term. Okay, let me go back to this number thing real quick. If I just made this like a 2 and a 1, dividing by the 2 and the 1, do I divide the 2, then the 2, then the 2, and then divide the 1, the 1, the 1? Or, I mean, if I have a 2 with an x and a plus 1, I can't divide each of those, right? 10 can't be divided by 2x plus 1, or 4 can't be divided by 2x plus 1. Like, there's just no way to do this individually when our divisor, the thing doing the dividing, is more than one term. So the option that we are left with, you're not going to like it, is long division. And it's possible that you've seen this before, but this may be totally new for you. Long division of polynomials. Okay, the good news is that when we long divide polynomials, we're using the same process that we use for long division with just normal numbers. It's that it looks a little more complicated, okay, but the basic idea is the same. So I just want to review some vocab and the process with normal division. If you didn't have a calculator and I said to divide 1057 by 4, you would start by putting the 4, I don't want to use green. Let's put the 4 outside of this division box and the 1257 inside our division box. Okay, so you'd set up for the long division, and the 1257 that's being divided, we call that the dividend, and the 4 that's doing the dividing, we call that the divisor. Okay, so if we were going to long divide this, we're going to start by setting this up. Dividend goes in the box, divisor goes outside the box. And how do we actually start the work, right? Because anyone could write a number in a box and another number outside of the box. Well, we start by dividing, right? And when we divide, I'm looking for how many times 4 goes into not the entire thing, or I wouldn't need this process. I want to know how many times 4 goes into just the first part of this dividend. So I'm just dividing 4 into 12. So what is 12 divided by 4? Well, it's going to go in 3 times. So we start with division, right? Just keep this in mind. We start with division, and then we put the result on top of the box. And then what do we do with it? Well, after we get that result on top of the box, we multiply. So the 3 times the 4 gives me a 12 to put here. And then what do I have to do with that 12? I have to subtract. So it's divide, and then multiply, and then subtract. So I subtract 12. I got nothing left over. And then I'm going to bring down the 5, and I'm going to do this again, right? I'm going to divide again. So I'm going to divide. How many times does 4 go into 5? Just once. And then I'm going to multiply. 1 times 4, which is going to give me 4. And then I'm going to subtract again. And then 5 minus 4 is 1. And then I'm going to bring down the 7, and then I'm going to do it again. I'm going to divide, then multiply, and subtract. So 4 goes into 17 4 times. 4 times the 4 is going to be 16. And then I subtract, and I get my remainder. Now, if I wanted to make a decimal and keep going, I could. But we're not going to do that with polynomials. We're going to leave this with a remainder. And so the next question would be, how do I write my remainder? So some of you might be thinking, oh, we'll just put an R1. I think when you first learned this, maybe 4th, 5th grade-ish, we do that, but that's not technically the correct way to write the remainder. The remainder of 1 is written as a fraction over the divisor of 4. So the divisor of 4. So 3/14 and 1/4 would be our correct quotient. That is the answer here. So the answer is 3/14 and 1/4. That's called the quotient. And then the 1 out of 4 here is called the remainder. Okay, so just some vocab, and again, the process that we're going to use for polynomials, it's the same process, it's just going to look a little uglier because we're dealing with polynomials. Alright, so what are we doing? And this is, again, we don't have to use this every time. If we're dividing, if our divisor is a single term, well, let's go ahead and use our quotient rule because that's going to be easier. But long division of polynomials is when the divisor is larger than a monomial, when we have more than one term there. That pink looks kind of bad. Let me read that a little bit better. I don't know. When the divisor is larger than a monomial, we're forced into this long division. Okay, so we're going to write the divisor outside of the box and the dividend inside of the box. That's easy. Everyone can set up the long division. And then we start with division, same way we started this problem. We start by dividing. And just like this, when we divided, we didn't look at how many times 4 went into the whole 1,257. We just went 4 into 12, right? What we're going to do with polynomials when we start our division is we're going to divide the first term of the dividend by just the first term of the divisor. So if I have, let's say, a 2x plus 1 going into a 4x squared plus 8x plus 3 type of deal. When I start my division, I will only be dividing the first term of the divisor, or dividend, by the first term of the divisor. So I would take 4x squared and divide it by 2x. That's my quotient rule. I would get 2x to the first, and that would be the first part of my answer. Okay? So don't write that on your notes because I'm going to erase all that, but just so you can see what I'm saying. The result is the first part of the quotient, so it goes on top of the box. Now once we get this thing on top of the box, we multiply. And here's where we use the whole divisor. So when I divide, it's just the first term and the first term, but when I multiply, I'm going to multiply here and here. So I'm going to get a 4x squared, and I'm going to get a 2x. Okay, so we're going to multiply the result by the entire divisor. And then I want to subtract. And I'm going to say draw your line and change your signs when you're subtracting. So when I go to subtract here, I want to subtract the 4x squared and subtract the 2x. So when I draw that line, I'm basically changing those signs. So these terms will cancel. Excuse me, and then 8x minus the 2x is going to give me 6x. I would bring down the positive 3 and then do it again. Okay, just like I would with normal numbers. Let me just get rid of all this ugliness. Okay, so we subtract. It's the same 3 steps we looked at before. We said divide, and then multiply, and then subtract. and you bring down the next term, you do it again until you have a remainder. So bring down the next term and then repeat the divide, multiply, subtract, the divide, multiply, subtract until you have a remainder. And then remember, when we write the remainder, what we're going to do is we're going to make it a fraction over the divisor. Okay? So, sounds a little complicated. It's definitely going to look a little complicated, but just take your time and try to follow the steps, and we'll be able to work through this. Okay? Let's try this first one. So because this divisor, this thing that that's going to do the dividing, is more than one term, that's how I know this is a candidate for long division. So I'm going to put x plus 3, my divisor, outside of the box, and I'm going to put x squared plus 5x plus 6 inside the box. Okay? So I'm going to divide, and when I start the division, it's just the first term divided by the first term. So what I'm dividing, and I'm going to do the work on the side over here because it's hard for me to keep track of all this in my head. I'm dividing x squared by x. And that's just a quotient rule problem. So 2 minus 1 is going to leave me x to the first. So that's the first term divided by the first term gives me the first part of my answer. That's going to go on top of the box. So x to the first goes on top of the box. Okay? After I divide, I have to multiply. Now when I multiply, I'm not just using the first term now, I'm going to multiply by both terms. So the x times the x, which is going to give me an x squared, and the x times the 3, which is going to give me a positive 3x. Okay? Oops. 3x. Let me get rid of these because it's going to be too many arrows. Alright, so I divided, then I multiplied, and now I have to subtract. So when I subtract here, basically I'm going to draw my lines, and basically it's just changing these signs, right? Subtract. X squared minus x squared makes those cancel, and 5x minus the 3x is going to leave me 2x here. And now I can bring down the next term and then do it again. Divide and multiply and subtract. So when I divide, it's just the first term divided by the first term. So just the 2x divided by the x. So what is 2x divided by x? Again, this is a quotient rule, right? 2 divided by 1 is still going to be 2. And 1 minus 1 leaves me no x's, so just a positive 2. So the plus 2 is the next part of my answer. Okay, so I divided those first terms, but now I'm going to multiply by the whole thing. So 2 times x, which is 2x, and 2 times 3, which is positive 6. Okay, so I divided, I multiplied, and now I'm going to subtract. So when I draw this line, I'm going to subtract here, which changes those signs. So 2x minus 2x makes those cancel, and 6 minus 6 makes those cancel. So I have no remainder, which means this is going to equal exactly x plus 2. X plus 2 is my answer here. Okay? Now, it's nice to be able to check your work. And I wouldn't do this every time just because it gets a little excessive, but if I said, the question is how do you check your work, right? If I said that 48 divided by 6 was exactly 8, how could you confirm that? Well, it would be to multiply, right? If you multiplied 8 times 6, it should take you back to 48. So the same thing would apply here. If I'm saying that x squared plus 5x plus 6 divided by x plus 3 is equal to x plus 2, that means if I multiply these, I should get back to this. And in fact, you can see I would. So x times x would give me an x squared, 2 times x would give me a 2x, 3 times x would give me a 3x, and 3 times 2 would give me 6. And combining these, I end up with x squared, 5x, and plus 6, which is exactly what I have here. So you could check your work if you wanted to. Again, I wouldn't do it every time, but if you really weren't sure, and let's say you were taking a quiz or something where it was worth a little bit more of your grade, then check your work. Okay? Now it's a little tougher when you have a remainder, and that's what's going to occur in the next one. And so let's try this next one out. And if you're feeling confident and you think you got this, then by all means, feel free to pause the video and give it a shot. Now this problem is written differently. It's written as a fraction, but our fraction bar means the same thing. This is division. So how will this look when I rewrite it? It's going to be the 2x minus 1 outside of the box, and the 2x squared plus 5x minus 1 inside the box. So I'm going to start the division. When I start the division, first term divided by first term. So it's just 2x squared divided by 2x. Okay, so let me do that work over here. What is 2x squared divided by 2x? Well, 2 divided by 2 is 1, and then 2 minus 1 leaves me an x to the first. So 1x to the first is the first part of my answer. And now I have to multiply that. And the whole divisor gets used here. 2x times x is going to be 2x squared, and then negative 1 times x is going to be negative 1x. So I divided and multiplied, and now I have to subtract. So I'm going to draw this line and subtract. So 2x squared minus 2x squared makes those cancel. And what about here? Negative negative makes a positive, right? That's why I said draw your line and change your signs. That's going to make a positive there. So 5x plus x minus a negative is going to be plus. That's going to give me 6x here. And then I'm going to bring down my minus 1 and then do it again. I'm going to divide my first term by my first term. So 6x divided by 2x. 6x divided by 2x, and let me do that work on the side. What is 6x divided by 2x? That's just going to be 3 because those x's will cancel. So positive 3 goes here, and then I multiply. 3 times 2x is 6x, and 3 times negative 1 is a negative 3. And now I want to subtract. So I'm going to draw my line, change that, and then again a double negative here is going to make that a plus, so I change that. These will cancel, and then negative 1 minus a negative 3 or plus 3 is going to make a 2 here. Now since there's nothing left to bring down, I'm done. That is my remainder. So this answer is going to be, this divides in exactly x plus 3 times, and then because this is a positive 2, we're going to say plus a remainder of 2, and that remainder gets written over our divisor of 2x minus 1. Now if the remainder had been negative, then we would put a minus in between those. Alright, and that's going to be our answer. Now this one is a little bit harder to check, although we could still use multiplication. If I said, for example, what's 49 divided by 6? Well, that would be 8 with a remainder of 1, right? So we would multiply here and then add that remainder back in to get to the 49. We could technically use the same process here. If I multiplied these two polynomials and then added the 2, it would take me back to the dividend, the 2x squared plus 5x minus 1. Again, I wouldn't do it every time, but if you really wanted to check your work, you could use multiplication to do that, okay? Now, I don't want you to feel too overwhelmed with this long division. You will see it in your practice assignment, and you will see one of these problems on your unit quiz. But in the big scheme of things, if it's something that you're just struggling with and not comfortable with, just do your best, okay? In the big scheme of things, it's not going to be crucial to what we continue to do as we move through the course. Now, the other concepts of combining like terms and multiplying polynomials or using the quotient rule, you absolutely have to know how to do those, and those will come up again and again and again. This process of long division is not going to be something that you see again and again and again. Now, it will come up again in future math courses if you're on the path to take higher levels of algebra. But for now, this is really meant for some exposure, so do your best with it, okay? But don't freak out if it's something that you never just master in this class, okay? Because this will be the only time that you're going to see it in this class. Alright guys, try your best on that practice, like I said, and then if you're needing some help or wanting some extra help, then